The Iterator Design Pattern by Samuel Tabi. Intent. So what's the purpose of this pattern? As the design patterns book discusses, it says to provide a way to access the elements of an aggregate object sequentially without exposing its underlying representation. So what that basically means is the iterator pattern allows developers the ability to access the data that they would need without giving them complete representation of how all of the data is being handled. Motivation. So the reason they decided to create this pattern, as Head First Design Patterns book discusses, it says that the iterator pattern allows the traversal of the elements of an aggregate without exposing its underlying implementation. It also places the task of traversal on the iterator object, not the aggregate. So that simplifies the aggregate interface and implementation and places the responsibility where it should be. So basically this pattern allows developers the ability to have many different data types accessible to them without giving up the information about it and how the data is being handled behind the scenes. This can be very handy when needed to incorporate different parts of different systems into a new project. So instead of spending hours of labor on trying to restructure all the code and re-implement the changes through multiple systems, the developers can just use this pattern and save themselves a lot of time, effort, resources, and a lot of frustration. The known uses for this pattern are Object Windows 2.0, the Botch component, a popular collection of class libraries, and wherever you need to traverse wildly different data structures. Pros. So reasons that people would use this pattern would be that it follows the solid principles of single responsibility and open-close principle. It allows for parallel iterations and reduces the need for duplicate code. And it's already a Java utility class. So some people might not want to use it because there are more than one ways to traverse a data object, there being variations of traversal. Like, for example, a traversal tree can be done in many ways, like a pre-order or in-order parse. If that event occurs, the iterator instance could be modified to work as intended, but that also requires some work. And sometimes it's not always the most efficient choice to use. Structure. So this is the class diagram for the code I used to represent the iterator pattern. I'll go through that later. But basically, so you have ESPN has many analysts, and what they do is each analyst, they want to pick their 3 favorite players. Mike does it using an array list, Mo does it using an array. So rather than have someone go and rechange all of these or ask one of these 2 analysts to change what they did, you can just create a sports analyst interface that's the iterator pattern, and that'll handle everything for you. Related uses of this pattern, well, you can use the iterator to traverse composite trees. The iterator can be used with the factory method to let different subclasses return a different iterator depending on the collection. The iterator and memento can be used together to capture the current state of iteration and reverse it if necessary. And it can be used to traverse composite trees. The works cited, I've used all of these websites and the books that were required for this class. So I'll go through the demo right after this, but I want to thank you for listening, and if you have any questions, please feel free to ask. Okay, so this is my code for the iterator pattern, and all this does is basically gets the players that both analysts Mike and Mo have sent in for their best players. It sends them to ESPN, and ESPN will show the players. The problem is Mo implements his players using an array, and Mike implements them using an array list. So ESPN will just create them as sports analysts, which just sends them back an iterator. So ESPN will go create iterator Mike and iterator Mo, and when it's called on to show the players, it'll just send Mike's picks to become an iterator, and then print all of the players, print out their information, their name, their sport, and their best year. It does the same thing for Mo's picks. And the player's info is just very simple. It's just the name, the sport, their best year. So when Mo creates his players, he adds them using an array and he returns them using an array. Mike does the same thing, but to fix this without using the pattern, there would have to be a lot more work done, and it would need either both people to commonly agree on one data structure, or have someone else come in and re-implement everything to use one data structure. What this does is it makes it very simple, very clean, and pretty easily gets you all the information that you need. Thank you.